In this first unit, we're actually going to go slightly out of specification order. We're going to be having a look at the following points from the specification. Now, a lot of these you should already know from GCSE. First of all, however, what is a network? Well, in the old times, we'd have a single computer known as a standalone computer. This is not networked in any way, it has no form of communication, it's a computer without any form of networking. That means it's not connected to the internet, it's not connected to a printer, it's no Bluetooth. As soon as we connect a computer to another device, it actually becomes part of a network. Now, that doesn't matter whether you're using Bluetooth on your phone to connect some headphones, or if you're connecting to a home network or a wider network such as a school network. The purpose of network really is to allow computers to connect together, to share resources and to communicate. So networks can be found in many different places. We have home networks which tend to be small, and in small organisations we have local area networks. The largest network that's available currently is the internet. We actually have two types of networks, a LAN, which is a local area network, and a WAN, which is a wide area network. Let's have a look at these two. Now, a LAN stands for local area network, and in simple terms it's a network which is connecting one small geographical area. So think of this as a network which is connecting computers and devices for a school or for a small company. It's not going to be over several different sites. It's all in one geographical area. When we're talking about devices on a network, we need to be talking about nodes. Each device, regardless of what that is classed as a node. So really the purpose of the LAN are to share digital information and allow us to communicate. We can share peripheral devices. Remember, a peripheral is a device which is not inside a computer, such as a printer and scanner. And a network allows us to share these. We can do some maintenance locally. So at school, all your computers can be updated with the latest software from a central point. This means it doesn't need to be done on an individual level. So the maintenance of a network can be much superior to having standalone computers. Sometimes this is called the distributed process. So a single process can be run simultaneously on different computers. And we can also use something called hot desking. And hot desking is used within businesses. Imagine you've not got your own desk, and every day you come in and you can choose a different desk to work at. It doesn't matter where, but you can log on to any computer. This is like a classroom in essence, that you could go onto any computer and log into any computer at any time and have access to all your files and your resources. The downside to a LAN really is that it does take a bit of expertise to install. Think about our school network. We have 3 technicians. These technicians are responsible for maintaining and building the network, so adding extra computers, fixing errors, and making sure the network runs smoothly. We can have a series of security issues. These are things which could stop issues on the network. So having passwords, as you know at the moment, you've got a password that needs to get onto the network. You'll have different access rights to the access rights of your teacher, and that's really important. At the moment, you can't install software on our school network. However, the technicians could. And also, there is a level of encryption embedded across the network. You're forced to change your passwords regularly, and this can be a disadvantage for a LAN as well. Now, another type of network is a WAN. WAN stands for Wide Area Network. And unlike a LAN, this can cover a large geographical area. This could be worldwide. You might have different telecoms companies using a WAN, but a good example would be a bank. Every time you go to an ATM, you expect to be able to take money out. All these different banks have different ATMs up and down the country, all connected to the same network. They're all in different geographical areas and all need access to that network so it knows how much money you've got in your bank. If it was a LAN, you would only be able to take it out of one cash point, and that would be at your local branch. Typical uses of WANs include the internet. Now don't get confused here. We talk about the internet, but the internet is actually just a network of hardware. It's the hardware that facilitates and allows us to communicate with each other. So these are the switches, the bridges, the routers and the modems. When we think more about going on to websites, we're talking about the World Wide Web. So just be careful about that. Large companies who are over large geographical sites, like a bank, would have a WAN, and universities. Quite often universities might have different campuses, so they would most likely use a WAN. Have a look at this summary and make sure your notes include everything that you can see on this screen. You may want to pause your video to make sure that you've done this. Now, we can get some very simple questions on networks in the exam, but it's really easy to actually throw away marks on some of these simple questions, and this is where we can pick up some easy marks. Have a look at the exam questions, try to answer them, and then once you've answered them, mark them and make improvements. We're now going to be thinking of network architecture. Look at this diagram on the left-hand side. This is what we call a client-server model. Our client-server models are a type of LAN. Have a look. Can you identify any key features of a client-server? Can you work out what's meant by a client-server? And can you use this diagram to tell me what you think the characteristics of a client-server are? Pause the video, then we'll have a look. So let's have a look at a client-server. A client-server is a series of nodes which are connected to a server or a series of servers. This server provides a service for the clients. Think of it like a shop. When you go into a shop, you have a client. They go in and the server or the person who's providing the service gives them the product they're looking for. They are the server. Now, you might have one server sat in the middle of this network. However, you might have a series of different servers, potentially connected via a switch. The kind of servers you might have are mail servers which hold your email. They might be print servers which manage the printing on the network, or file servers like we have in school. You can save your files on our file server, although nowadays most of the time we use things like Google Drive. You'll have other servers which might provide other services such as the internet. This is the client-server model. When a client wants one of the services being provided, it sends a request, and this is responded to. And this is this client-server relationship. Now, for this type of network to work, you'd expect all the clients to have an individual username and password to ensure security and protection. It's not always necessary, but usually this would be the case. Now, on a client-server network, you could potentially also have a wireless access point. This is so that people on a wireless network can also access some of those services. Now, for this network to be successful, centralization is important. A lot of the services that can be provided on the network can be done directly from the server. So things like antivirus or updates can be transferred from an individual server. However, in this model, if our server fails, this can be a serious problem. It can mean the network is going to stop working. The second type of LAN that you need to know is what we call a peer-to-peer network. A peer-to-peer network has a series of computers which are all connected. This could be remotely or via a set of wires. Have a look at these three questions. From your previous knowledge and possibly your networks at home, can you try and answer these questions? Pause the video now and answer those questions. So our peer-to-peer network, remember, is another example of a LAN. It's worth noticing that we're going to use these peer-to-peer networks in a small business or at home, quite often wirelessly, where we're not going to have lots of wires floating around. You'll see each computer is connected directly to each other computer, which is why it works particularly well when we have a wireless network. Remembering back to network topologies from GCSE, if we needed to connect every computer to each other, this would be a mesh network topology, which can be quite expensive to develop. In this position, there's no server. There's no server which is providing a centralized service to the others. Each node on our network has an equal status. Because each node has an equal status, this means that each computer can work independently from each other. So if one computer breaks, all the other computers can carry on working. Remember that a key issue with a client-server model was if the server breaks, then the network is really going to be grounding to a halt. It can also be cheaper because there's no server and you don't often need that network admin. You store your files on your individual computers as you'd expect. There's no file server. And you can share those with other computers quite easily over that network. You can make shared areas that you can share data and resources with other people. As computers become more modern and network technology becomes more modern, we see more peer-to-peer networks in operation. This is because of the use of communications technology and some of the resources that we can actually use out there on the internet. You'll have noticed tools which are collaborative software such as Google Slides. Well, these support collaboration across any network, but on a peer-to-peer you can save those on one computer and everybody can still access them. And this is the same kind of principle on a peer-to-peer network, that you can work collaboratively where computers are accessing the same document, but that's on one computer. However, there are some disadvantages to a peer-to-peer network. Security can be an issue. If a piece of malware infects one of the nodes on the network, then this can spread quite easily to other nodes. This is because nobody's centrally managing security. Nobody's forcing you to do updates for virus protection or anti-malware, and then nobody's setting the network security as well. Now, in modern days, most people are going to have an antivirus, and that's not going to be so much of an issue. But it's always worth keeping in mind that this could be a problem. So here's my summary of a LAN and a WAN. Have a look through these notes and make sure that you add anything that you've missed to your notes. There might be the odd word or two or key term that you're unfamiliar with. Have a look at these, make sure you do a little bit of extra research around those, such as leased lines. Finally, here's a summary of a client versus a peer-to-peer. Remember, these are examples of the LAN network architecture. Check your notes and make sure that you've included everything on this slide.